X-rays are made. And when I can, I'm going to pull in some of the things that we've talked about already and how they pertain to this. All right, X-rays. Are made in a glass tube, and that's what I've illustrated here. This is a glass tube. And, you know, I often talk about it in terms of it's like a big light bulb. So it's glass. And another thing about that glass tube, it's X-rays are made in that glass tube, and it has a vacuum. You know what I mean by vacuum? Anybody? When I say it's a vacuum, what do we have?
Absence of air.
Absence of air. Very good. What are those things you see on TV you can buy to put up your vegetables?
Okay.
Yeah, that takes the air out, right? And it collapses. So this tube has no air in it, and I'm going to explain why down the road. All right, so here's a circuit. It has alternating current. And there's a switch. This is called a filament. Alrighty. What does it look like in real life? A what? Well, yeah, it is. See about all your goods here. Do any of these ballpoint pens have a spring in them? Yes. All right, so you've played with a ballpoint pen, no doubt, right? When you take it apart, what do you find in there? A spring? That's what it looks like. And that's what I tried to draw there. So we put current through this circuit, and primarily through the filament, and it gets
hot.
Hot. How did you know that?
It's my job.
Oh, is it?
Yes.
To know that.
Yeah, it's my job in the Air Force.
You told me.
Yeah.
It was.
NDI.
Oh, okay. So we put current through. And you know, when I was teaching in Chicago, we had a great resource. We could go to a factory, and I would take the students to the factory where they made X-ray tubes. And they made it from scratch with raw metal. They had glass blowers that made that. All right, so you're going to put current through this filament, and I'm telling you, you won't believe it. It would light up this room. It gets so hot.
What is the filament made of?
Tungsten, and you need to know that. It's made of tungsten, which has a high melting point. It can take a lot. Filament is made of tungsten. So we put current through it, and it gets red and white hot. And there's a device in this circuit that controls the amount of current. It's called the what? The switch. Now, here's what's happening at the filament. What do those look like? Do they look like a letter? What letter? Those are electrons. They're boiled off. And that is called thermionic emission. When you boil electrons off the filament, it's called thermionic emission. And electrons have what kind of charge? Negative. And we put a little cup around here, a little device that holds them in there nicely. Now, this circuit here, now, depending upon how you use the switch, determines how many electrons you're going to boil off. Okay? Now, let's take that little circuit there with the switch that's changeable. Where in your personal life have you ever adjusted a switch like this? Well, you've done this before. All right, so somebody here, when we leave today, you're going to go get in your car. You're going to start your car. And then what do you do after you put your seatbelt on? Put it in drive. And did I miss anything that you do?
Well,
You're driving now. No AC. Turn on the radio. Right?
You're supposed to do that before you drive.
Pardon me?
You're supposed to do that before you drive.
All right, so we have Director of Safety.
Some cars won't even let you do it after.
Pardon me?
Some cars won't even let you do it once you put the car in drive.
Really?
Yeah.
Yeah.
that would,
It's really
that would
annoying.
drive me
It's
crazy.
really
You know, I heard that cars made in
Hard
Europe
for me.
do not have AM radio.
Oh, what?
so they only
Nobody
have,
listens
They
to
only have
radio
FM?
anyway.
I heard
Mine. Mine is all of it.
Made in Europe, drive in Europe.
Bluetooth.
All right, so you're turning the radio on, and what else do you adjust?
The AC.
Not today, you won't.
Oh.
The volume, right? Brianna, thank you. The volume, right? And that's what this is. It's this circuit. You control the flow of current for volume up, volume down. You control the flow of current here for number of electrons you boil off. Now, with that on the table, where else in your personal life have you ever done this maneuver?
Toaster.
Okay.
A blow dryer.
I feel like there's something
Because you
specific
adjust
you're
it on the
aiming
blow
Oh, I
for.
am. There's something. I'm sorry. You guys have an electric stove?
Yes,
You ever turn it? And it gets bright red, or you turn it, then it goes? And there's one more. There's one more that you all have, that many of you have here. It's the classic what? You have a dimmer switch in your dining room?
No.
You know what I'm talking about?
Yes.
That's what we're talking about, yeah.
Yeah.
That's what that is. That's what it is. All right, so we boil off a bunch of electrons. All right, and then you need to understand this is called this side of the tube is called the cathode, and it's referred to as the negative side of the tube. And here's a simple way somebody told me years ago. They were trying to remember cathode side from the other side. In other words, someone said,
Cats.
huh?
Cats.
Cats, and what about them?
They are jerks.
That's it.
Cats.
Cats have a negative attitude, don't
Yeah.
they? So that's how they remember it. Right.
I don't want to do that. I just don't like
Cats?
My cats.
How many you have? All right, so that's the negative side. The negative side, so over here, we have something called an anode. Again, it's a disc. It's about the size of a jelly donut. It's made of tungsten.
The both filament and.
Yes,
the disc
because,
and
Steve, we're talking about a lot of heat. That's called an anode, and it just, the anode can spin. Like I said, it's a disc about the size of a jelly donut. It can spin, or it can be stationary. And I'll give you examples of where the two differ. All right, so we've got all those electrons boiled off over there by thermionic emission, and then when you make your exposure, you shoot high voltage through this tube. High voltage. It shoots through this tube and it hits that anode hard. All right, so.
Is the target always like right across from it, or can it be?
No, it's very close. Yeah,
Okay.
it's very close. So that voltage comes along and bang, it picks up those electrons, it shoots them across, and it hits the anode. All right, so, did I ever ask you guys, go through the scenario of driving a nail? No?
Yes.
All right, so what did we conclude we get? Heat where?
On the nail.
On the nail, it's the same here. Those electrons hit that anode, and we get two things. We get two things over here. Pardon
Yeah,
me?
there's an
Oh,
What? I heard it
E on the end? Or is that
anode.
on the anode.
ANODE or
A-
AONDOD? Okay.
it was a brief. That was a test.
As radiation therapists, attention to detail is very important, right?
I spelled it with the E, and I was like, wait. am I
All right,
wrong?
so what do we get here when these electrons hit the anode? Two things. What's the goal?
photon.
The goal is to make what? X-ray photons? And what's the other thing? We get heat. It's matter hitting matter, right? Okay. It's really an inefficient process because it's like 99% heat and 1% X-ray. It's pretty inefficient, but what are you going to do? This is how it works.
Is this essentially what's going on when you plug in a personal heater? Like how you get the heat from your heater?
Well, you're heating up material to give off heat.
Not
That's over
necessarily-
here.
But not
Yeah.
necessarily like tungsten, it could be.
It's another material, yeah. But it has to have a high melting point. And you can see your heater gets red hot. So we got X-rays hitting this anode. We have electrons hitting the anode. They're flying all over. All we care about is what comes out here. Okay, I think this is a term you use in radiation therapy. Port. Do you use that term? The opening here where the X-rays come out. All right, now there's something called a diode. Why don't you guys Google that? What's it say about a diode? What is it?
Semiconductor that allows flow easily in one direction, but severely restricts it from the opposite direction.
Okay. Anything else?
Has two electrodes, an anode and a cathode.
There it is. All right. Does this have two electrodes, an anode and a cathode? So the question is, this will be on your test. An X-ray tube is a diode, true or false? True. Yeah, here. Okay, now, remember I said earlier it's a vacuum? Why do we want it to be a vacuum inside that glass envelope?
So it can't bounce around into any molecules there.
You're right. When those electrons go from anode to from cathode to anode, we don't want them hitting any air. So we take it out. So what's the biggest product on that interaction on the anode? Heat. All right, so what do we do about, and next week I will bring in some anodes for you to see what heat does to them. So what can we do to that anode to dissipate some heat? In other words, get rid of it. What do we do? What can we do? What? Yeah, there's some cooling system. There are some tubes that are encased in oil that helps, if the oil circulates, takes heat away. What we do is that anode rotates and spins. So those electrons are hitting what? 360 degrees, not one spot. Are you with me? Okay? It spins. Therefore, it's bombarding 360 degrees around the disk, not one point. So that's called, in general radiography, in your CAT scans, it's a rotating anode.
What would happen if it just hit one spot?
Yeah. Go ahead.
Float?
Yeah, it would crack. It would look like this. I'm going to draw the face of you. And you're going to see this when I bring it in. So it spins. You're going to see a bunch of this, which is normal wear and tear. But if it didn't spin, you'd get,
One spot gets super heated.
bang, you'd get a big pit. It would crack it, especially if it was cold. In other words, not warmed up, a few exposures, put a little heat on it, but yet it would stick. Now, so in CT and X-ray, we use the rotating anode, but there is a profession that uses a stationary anode. It doesn't spin. Where might that be? And you've all, I would say, have experienced this. Where else do you get X-rays?
The dentist.
You know, they pull that thing down on you, right? All that stuff's in there. But that anode doesn't spin. It's stationary. And it's pretty much the same exposure for everybody. So dental, stationary anode. Now, let me come over to this. This is called a what? Sine wave, and it demonstrates current flow. Right? All right, so didn't I just say these electrons go from cathode to anode? You with me? Everybody? That's here. One direction. Do we want anything to go from anode to cathode? Huh? No, it's not going to make X-rays. So when you look at this, in the event of producing X-rays, if we have this, there's a time frame here where what's happening? Nothing, right? Until we get back to that. This is pretty inefficient, isn't it? All right, so what do we do? No, I don't. All right, so inside there, computers operate on direct current.
Didn't we talk about that?
See that little thing there? Okay, and your computers at home have it too? It does this. Now the current's what? Going in one direction. That's what X-ray tubes like. That's what computers like. Okay? It's rectified. We flip the downside up, didn't we? It's all going in one direction now. Everything's good.
This exam's gonna be hard.
Pardon me?
This exam's gonna be hard, extra hard.
No.
So, is that wave not considered alternating current anymore? Is that direct current now, or is it called something entirely different?
Well, you're standing on second base. Let me bring you home.
Oh.
It's called pulse. Look at that. It's called pulse
Uh-huh.
direct current. Right?
That's direct.
You like that? Pulse direct current. Because it's pulse, as you can see here. If this is time, what's happening here?
Nothing.
What's happening there? What's happening here? Nothing. It's pulse. No. Let's go back to illustration A there. So you guys are all comfortable that nothing's happening here, right? Right? What's happening up here? That's pretty good. All right, so what's happening on those top dots? Those electrons are hitting the anode hardest. How about here? Weaker, better than zero. And because of that, our X-ray beam that comes out here, all these X-rays are what we call, do you know this term? Polyenergetic? Do you know that term? Is your therapy beam that way? Is it polyenergetic? Okay. Your X-ray beam is polyenergetic. In other words, the beam has a lot of what? Different energies. It would be great if we could create beams that are what? Monoenergetic. Make beams that we really need. All these weak X-ray beams are done. What happens to those? We filter them out because they don't serve any purpose other than skin exposure. So we filter them out. Okay, one last thing for this. Now, what happened? What did I mix them up?
You're the culprit. She was asking us yesterday, which one's blue, which one's red?
All right, so this, a couple more components here. This is the anode. All right, it's attached to a device here called a rotor.
What's the T for under the diode word? I missed when you put that up.
Oh, the X-ray tube is a diode,
Okay.
true or false?
Okay. I think I was looking at my notes when you were that there. I'm like, where's that T
I
from?
have to say, you guys, you don't have your fastball. All right, the rotor. The rotor turns the anode. Remember I said it spins? The rotor turns it. How do we make it turn? This is what? What's that? What's part of this? What did I say that was? It's glass. This rotor is in the stem of the glass here. This is incredible. Outside the glass, this glass stem, right here. What am I drawing? Huh? What? Electromagnets, right? It's outside the glass.
I know. What's drawn in glass? Yeah, what?
So, it's outside the glass. Now there you see two of them, right? And then there would be one on the other side and one right here. So we're going to have 4 electromagnets outside on the glass. And they create, when you put current through, they create what? Magnetic lines of flux. And through the glass, these magnetic lines of flux do what to the rotor? Make it turn through the glass. So that's how we get it to turn, with an electromagnet. Stator, rotor, be able to differentiate. The rotor turns it, the stator powers it with electromagnetic induction.
So, okay, you didn't mention stator before. What part of that is the stator?
Oh, the electromagnets are called stators.
Stator,
Yeah.
With a D, S-T-A-T?
No, S-T-A-T.
They power it.
They power it. Now, this test you're all worried about isn't until after the break. Is that any consolation?
No.
No? Did I ruin your break? No. All right, so just to summarize the component parts of the diode, the X-ray tube, anode, cathode. We produce the greatest interaction is heat. We create a polyenergetic beam. Know the function of the stator and the rotor.
Well, you said rotor again. Like what is it? The stator
Oh.
powers it and the rotor.
Turns it. It's like,
I just want to make sure. I
Yeah.
have your words.
here's the rotor, here's the anode, and it turns it. And the stator operates on electromagnetic induction.
Induction, electromagnetic.
Just, you're just like me. No drawing? No yeah.
It's okay. Most of this video is on
When
the
they turn on the
drawing.
stator, does that sound
I
right?
should've done
Am I
my
saying
big
it right?
one,
They
though.
turn it
I
on,
didn't think about it.
activate
Oh
it.
shoot.
Affects the, tungsten? Does it actually act on the tungsten to turn it? Or does it turn something else that turns the tungsten?
It turns the
Turns the tungsten itself?
It triggers the electromagnet. So when you make an X-ray exposure, okay, it's twofold. I'm trying to think. So, it's like pushing the gas down halfway, the gas pedal. When you go halfway down on the gas pedal, in this scenario, okay, this fires up. You with me? This starts to spin. And when you make that X-ray exposure, put your foot down on the gas, they shoot across. What do we get?
Heat.
And
Electron.
X-ray photons. Guys, differentiate now photons from electrons. That's how it works.
So then what part is specifically the rotor, the actual anode? Like on the, on
Okay,
that.
the
drawing?
anode is here. This bar, okay, connects to the anode. It turns the anode.
Okay.
Yeah.
I missed that part.
And when, you know, this is beyond the scope of what I want to do, but inside here, to make this thing really spin, there's ball bearings, little ball bearings.
You always been a physics teacher, or did you do something else before physics?
Pardon me?
You always been a physics teacher?
Well, we have to teach a lot of different things. I'll tell you a story. I was mentored when I was teaching in Illinois. This goes back to the 90s. We had a physicist who was actually assigned to our radiation therapy department. He mentored me through all this. You're going to love his name. He was from Spain. His name was Dr. Jose Cuevas. Don't you love it? He mentored me through
That's
this.
deep though.
So this is how we produce X radiation. Okay, remember it's polyenergetic beam. Any questions on this? We're going to pick this up again next week.
It's really weird, but I know Jose Cuevas.
And
I know it's one of my friend's dads.
Morgan, you're gonna be sick.
is he from Spain?
How
How old is he?
I don't know how old he is.
Is he older? Would he be
They're
older?
Puerto Rican. That's all I know.
Oh, he's from Spain.
Oh, okay.
He came over from Spain, my friend, went to the University of Iowa and stayed there through his PhD.
Oh,
And he was real European guy.
I wonder if it's the same guy. That'd be weird.
He's a real
Does he
European.
live here?
This was in Illinois where I knew him. This was in the 90s.
Did you like it in Illinois?
No.
Yeah.